Today we're going to be talking about the 6 trigonometric ratios and how they go in line with the unit circle and how we can use them there. So the first thing we have to figure out is what the heck are the 6 trigonometric ratios. So we have seen sine, cosine, and tangent already, and you learned those in geometry and we saw those earlier as well here in Algebra 2. And so just to refresh your memory, the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. So why are there these y and r's and x's over here? So if we're looking at something that is in the unit circle, remember it's called the unit circle because the radius is 1 unit long. So here, in any of these triangles, this is the x direction, this is the y direction, and then this is r because that's the radius no matter where we are along the unit circle, okay? And one thing again that we need to remember is that the radius, this side here, is always 1, okay? So if we are finding the sine, we're going to take the opposite, which is y, and we're going to divide it by 1. Well, since it's anything divided by 1, it's just going to be that y value. So the sine is going to be the y. The cosine is adjacent, which is x divided by the radius. Well, x divided by 1 is just x, so the cosine is x. And then tangent is opposite over adjacent, so y over x, and that's going to just stay like that. So anywhere you see an r here, those are just 1s, okay? Now there are 3 what we call the reciprocal ratios as well. So there are sine actually matches up with cosecant, okay, because cosecant is the hypotenuse over the opposite. So that's just the reciprocal. Instead of having opposite over hypotenuse, we have hypotenuse over opposite. So those are reciprocals. And then the next one that we have is secant. So cosine and secant go together, because those are reciprocals, and then tangent and cotangent. So, and those are just reciprocals of each other. And to be honest with you, I would never normally write them in this order. What I'm going to do, and what you're typically going to see, is sine, and I'm just going to use their abbreviations. So sine, cosine, tangent, and then cosecant, secant, and cotangent. Okay, so this is typically the order that you're going to see them in. And I know I probably went really fast with that, so you can pause the video and write down anything that you feel like you need to. Okay, so how the heck do I keep track? Obviously we know sine, cosine, tangent. Perfect, that's easy. And it makes sense that tangent and cotangent go together because they sound the same. In each of these pairs, there's only one of them that can start with C. Okay, so sine does not start with C, so it needs to be paired with cosecant. Cosine starts with C, so it needs to be paired with something that doesn't start with C, which would be secant. And again, we already talked about that tangent and cotangent naturally sound like they go together. Okay, so these are the 6 trig ratios. You need to know these. Okay, and we're going to put this into practice using our unit circles. So hopefully by now you have been practicing and memorizing this unit circle. Okay, so I left you off here in the previous day's video. So I went through and I just filled in all of these, and I did color code them for a reason, because they do all have the same reference angles if they're in the same color. So here at 30 degrees, it has a 30-degree reference angle. Well, 150 also has a 30-degree reference angle. So does 210, and so does 330. So those degree measures, in degrees or radians, doesn't matter, have the same reference angle, which means their coordinates are going to be the same. We go radical 3 over 2 and then 1/2. So the long leg here is radical 3 over 2, the short leg is 1/2, and since we went left, that's why that makes this negative. Here we went down, that's what makes the y coordinate negative, but they all share those same coordinates of radical 3 over 2, 1/2. And the same thing would happen with your 45-degree reference angles, so that's why it's important that we know reference angles for this. And then our 60-degree angles have the same coordinates okay? Just positive or negative depending on which quadrant you're in. And then the 0, 90, 180, 270, 360, those degree measures are really easy to kind of keep track of and know, okay? So this is all going to be very important for us as we go, okay? Putting these two things together. So we are going to find all 6 trig ratios for a given angle. And we're going to do a couple of them in degrees, and then we're going to do one in radians, just so we have a hang of it. All right. So we have 30 degrees, and that means that we're going to need to know what the coordinates of 30 degrees are. Now, I guess I should do this before we get into answering these questions. So how the heck are you going to memorize those coordinates of the unit circle without going back and doing all of those 30, 60, 90, and 45, 45, 90 triangles the way that we did before? So I use the hand trick to remember this, so I'm going to quickly talk to you about the hand trick. So you're going to use your left hand, and this represents the first quadrant. So we have 0, 30, 45, 60, and 90 degrees, and those are the 5 angles that we had there in the first quadrant. So if you're looking at, let's say, 30 degrees, okay, you're going to put that 30-degree finger down. For all of these, you're going to take the square root of the number of fingers that you have on the left. So the square root of 3, we don't know what that is, but we divide it by 2. So square root of 3 over 2 is the x-coordinate. We're going to do the same thing with the fingers on the right. So we have 1 finger, the square root of 1 is 1, and we put it over 2, that's 1/2. Okay? Let's look at 60 degrees. So we have 1 finger over here on the left, that's our x-coordinate. So we have square root of 1 is 1, divided by 2. On the right, we have 3 fingers, the square root of 3 is the square root of 3, we divide that by 2. So that's square root of 3 over 2 over here, right there. Whereas for 45 degrees, we would have square root of 2 over 2 and square root of 2 over 2. And it even works for those 0 and 90 degrees. So let's just look at 90 degrees. So we have no fingers over here. The square root of 0 is 0, and 0 divided by 2 is 0. And over here, we have 4 fingers. The square root of 4 is 2. 2 divided by 2 is 1. So once you know the first quadrant, you're good to go. The reference angle is important because if I know that I'm at 150 degrees and that has a reference angle of 30 degrees, well, I know that 30 degrees is radical 3 over 2, 1/2. And since 150 degrees is in the second quadrant, my x-coordinate is going to be negative. Okay, and you could do that for any of these. So that's why it's super, super important to know the first quadrant especially, and know your reference angles to know what you got going on. All right, so then let's go back to this. We're going to find all 6 trig ratios for 30 degrees, okay? And so we know that the coordinates, so 30 degrees is our pointer finger, so we know that the coordinates of that would be radical 3 over 2 and 1/2, okay? And we need to find all 6, so sine, cosine, tangent, cosecant, secant, and I'm not leaving the proper space there, but that's okay, and cotangent. All right, again, each pair starts with C. Now, going back to what we had here on the first slide of information, sine is y over r, but remember we said that r is just 1. Everywhere we have an r here, that is just 1, okay? And that h down there should have been an r, not a h, but that's okay. It's besides the point. All right, so then that means that y divided by 1 is just y. So our sine is just the y coordinate of any of the points that we're at. So that means that the sine is 1/2. The cosine is just the x coordinate based on that same explanation there. So that would be radical 3 over 2. Now, tangent is the y over the x, okay? The y over the x, because if you're looking at your triangle, this would be your y over here, this is your x, and this is your hypotenuse of 1, opposite over hypotenuse, okay? So with this, our tangent is going to be the y divided by the x. Now, we've done work like this before. When you're dividing fractions, you're going to take the second one, and we flip it, and then we multiply. So the 2's go away because 2 divided by 2 is 1. So we're left with 1 over radical 3. Are we allowed to have that as an answer? So nope, we got to rationalize. which would give us radical 3 over 3 for our tangent, okay? Now that we know those three, we're just going to take each of those and find the reciprocal of them to get the cosecant. So for sine of 1/2, then that means that the cosecant, we would flip that to be 2 over 1 or just 2. Here we're taking radical 3 over 2 and we have to flip it. So we would flip it to be 2 over radical 3, but is that allowed to happen? So no. So we have to rationalize. And we get 2 radical 3 over 3. Now, cotangent, there's kind of two ways that you can do that. We can take this and we can flip it, but that means that I'm going to have a radical in the denominator, which I'm going to have to rationalize. Not terrible to do, but I'm actually going to go back here to this. If I take that and I flip it, if I take 1 divided by radical 3 and I flip that, I'm automatically just going to get radical 3. You can put it over 1 if you wanted, but then you just have your answer instead of having to rationalize and simplify along the way. All right, so let's take a look at another one here. So we're going to find all 6 trig ratios for the given angle. Now we're at 240 degrees. So think in your mind, what quadrant are we in for 240 degrees? So that's going to be in the third quadrant, okay? We know that in the third quadrant, both x and y have to be negative. Okay, so whatever they are, they're both negative because we know we're in the third quadrant. Okay, 240 has a 60-degree reference angle. So 60 degrees is our ring finger. So that means that the coordinates of this are 1/2 and radical 3 over 2. And again, they're both negative because we're in the third quadrant. Okay. All right, so we're going to do the same steps again. This one we'll go a little faster with. Remember, you can always pause the video if you feel as though things are moving too quickly. Okay, so sine again is the y coordinate, so we're just going to take that. And cosine is just the x coordinate, so we're just going to take that. Tangent is the one that's going to require the most amount of work, so tangent is y over x, or sine over cosine. That means we're going to keep the top one the same and flip the second one. But I'm going to keep that negative in the numerator so I don't forget about it. So I know a negative times a negative is going to make that be a positive. And the 2's go away with each other. So when we multiply these, we just get radical 3. Okay? Now we're going to take these and flip them. And you have to make sure you're rationalizing as well in this process. So negative radical 3 over 2, it is going to be negative. When we flip it, we would get 2 over radical 3, but we know we would need to rationalize. And so you don't have to, if that makes sense to you, you don't have to show that you're rationalizing. Okay. The secant, if we have negative 1/2 and we flip that, we are going to get negative 2. And then radical 3, if we flip that, remember that's over 1. So if you flip it, it would be 1 over radical 3, which we would need to rationalize to be radical 3 over 3. Okay? So we're going to do one more quick example here where we are looking at something in radians. Okay? And I'm actually going to change this to be 5 pi over 4 radians, which means that we're counting radians. Okay, so 5 pi over 4, nope, let's make this be 7 pi over 4. All right, so 7 pi over 4 is going to be in the fourth quadrant. It is a pi over 4, which means it's a 45-degree angle, which means we have radical 2 over 2 and negative radical 2 over 2. Sine is just the y coordinate. Cosine is just the x coordinate. And then tangent is sine over cosine. But if I take the negative radical 2 over 2 and divide it by itself, we have a negative divided by a positive. That just means that our tangent is going to be negative 1. Here we would have cosecant, so we are going to need to flip that and rationalize. And the negative 2's cross off.